When you see your computer, one thing that they leave off or they turn off is what we call file types. So this, when I look at this, you'll see this dot right here tells us the type of file, and over here, this extension, this tells us the type of file it is. The only programs are these guys right here that end with exe. Those are executables. And we also have COM. So we have two types of programs. We have a COM file, and this is what screws people up, because we go to these websites and they end with .com, which means commercial. Well, in Windows, a program file can end with .com. So you go there and you click on a link that says .com, and what could you have just done? You could have opened up a program file on your computer and gave it permission to do that. So be real careful, and that's a problem that we have. So most of the time, what happens is Windows turns off file extensions for non-file types. So if I tried to run this, it would give me in problems, because this is not a program. This is data used by a program. This is data used by a program. That's data used by a program. That's data used by a program. That's data used by a program. Does that make sense?
What does the word stand for?
What's that? You're thinking about internet. You're thinking about internet, and I'm talking about programs. Okay. So internet ORG is just one of the top level domains called organization. It's an organization. So if you went to NAFTA, like National Fire Protection Association, it's probably got an ORG as a top level domain. Okay. And what those do, so don't get internet domain names confused with file names. Completely different, right? Y'all understand that? So what they do is they turn off extensions. But what we have the ability to do is when I install Windows, when I install Microsoft Word on my computer, y'all listen to this. Every time you save a document in Microsoft Word, it gives it a .doc extension. For the old versions, the new versions use an extended version, .docx. So what that means is, so PDF, these are professional document format. So the program that runs this is Adobe Reader. Y'all understand? Does that make sense? This is a program. If I double click on this, it's going to launch a program. If I double click on that, we don't know unless we can do something. So just about all the applications that you create, these big applications, anytime you save a document file, it automatically adds an extension to it that belongs to it. Now, if we can do that, then what we can do is we can set up what we call a file association. I don't know if y'all have ever double clicked on a file and a box pops up and says that it don't know what program to run with that, because you're trying to open a document file and it has not been associated with a program.
Actually, open it, a couple options.
Huh?
Actually, a couple options.
Yeah, and you got to be real careful, because normally down at the bottom it says always open this file with this program. If you click on that and it's the wrong one, then you got to figure out how to go back and get it out. So in program files, we have folder options. I think this is where we go. So the folder options that I've selected, so by default, they have this guy right here selected. What's he going to do? Non-file type. So that comes as default. So when you look at your folder, all you're going to see is file names. You're not going to see, you can't distinguish whether they're program files or data files. Does that make sense? Let's see. So this is folder options. Let's see, I might have to search for this. No, I probably want to go to. This will probably tell us how to do it. So what I do anytime I get a computer is I turn on file. I want to see what type of files there are. Right? Does that make sense? Associations associates a file with a what? Application. So if I open up Microsoft Office, what it does automatically is it associates all its known file types. So what that means is once I have a file association set up, then I can come up here and I can double click on a document file. So this is not a program file, right? And it automatically do what? It automatically open the application that does what? Associates those files. So when you go out there and you double click on that, so the actual file extension for the it shows, well, no, it shows what type of file that is. So a exe means it's a what? It means it's an executable. It means a program file. A .com on here, not on the internet. A .com on here means it's a program file. Yeah, what those mean on commercial is what we call a top level domain. What it does is we know now that everything out there that uses the TCP/IP protocol addresses with an IP address. Right? You understand? So if you knew the IP address from Intel, you could type it in on your address bar and you'd be through. But the problem is, and I think what we related it to is that we related it to your cell phone. I've got tons of names on my phone, but I don't know their numbers. So what I've done is I've done what? I go in, when I check my wife's name, it goes in and matches that name to a what? To a number. Well, that's what DNS does. So DNS allows you to use universal resource locators, which most people call addresses. So that up at the top is called a URL. It's a universal resource locator. I type in a name and then I specify a DNS out there. So when you say .org and when you say .this, what you're doing is you're specifying a DNS server. It goes out there and hits that DNS server, and that's where it matches what? A name to the IP address. So you address by IP, you don't address by name. But what these DNS servers do, it allows this company to give their website a name instead of an IP. I mean, it's still got an IP address, right? You understand that. And what we can do now is I can come up here and I can type in www.lawsonstate.edu. Well, as soon as I said edu, it went out to the DNS server for all edus, found Lawson State, matching it to 207.157.something. And then we transfer information with that IP address, right? You understand? So to actually address these websites, you would have to know all these IP addresses. And think of all the places you go. If you want, you would have to know the what? To name, yeah, because you can come up here and just type in Walmart. You don't even have, you just type in Walmart right now and it'll pop up, it'll go out and automatically goes into whatever search engine that you specify as your default. Now we got all these search engines that are not DNS. The search engines, you just start typing in words. And automatically, if you don't start it out with like a www or a dot or something like that, you just type in a word, then what you go, it sends you to your default search engine, then it starts popping up a list of what? Names. You click on that, then you get the .coms and the .edus, then it goes to the DNS server and it picks it up. The internet is a lot easier to use than it used to be.
Hey, don't we get this for free?
What's that?
Microsoft Office.
Yes, it's on there. All you got to do is have a Lawson State email address, and you get Microsoft Office 365, which is basically the newest version. I don't know what version it is. I think it's 11. You get it for free. I knew that, right? And it's a really, really good deal. Dow 10, it doesn't make any difference.
What are those numbers?
It's just a number they decided to give to the free version of you, but I can't find anything that is different between the 365, which I have on my computer. No, I don't. I think I got 365 on my computer at home on my Windows 10. But I don't think it would. I don't even know. I think Microsoft Office. In fact, I know it does. Still runs under Windows XP. So it's still, if you got even a Windows XP. But now I don't know if the 385 will run under Windows XP or not. But I know 10 does, or 7. I know 7 does. The college has 10, but the way they have it set up is that they won't let you install it unless you belong to the LSCC domain. All our computers are not on the LSCC domain. All our computers are on our domain, LSCC-MET domain. So we have to put Windows 7 on those machines, but still Windows 7 and Office 7 and 10, I can't find any difference in those things either. I was trying to figure out, guys, where to set up file associations at. It's up here. So if you ever get, so file associations is when we do what? It's when we associate a data file with a true application. So instead of me trying to load the application and then load the data file, what I can do is I can double click on the data file, and if an association has been set up, it automatically does what? Launches the application that belongs to that application. So control panel. So what I was trying to do is I was trying to access another drive. So if we come up here and look at these, and I'll get it on Windows 7. Nope, don't want to do that, Rich. So this is why I got to get rid of all my video files that I hadn't uploaded, because it's filled up my C drive. So I can access these computers with just knowing they're what. Yeah, so we use IPs. We don't worry about names. And then but if I come up here and look at any of these files, then what we see is we'll come up here and see .ap 14. So this file is automatically associated with the port. So if I had a program on Windows on Siemens written for S7, and I clicked on this, it wouldn't work, right? It wouldn't work because it's the wrong one, the wrong application. So what's so neat, if I just come over here now, since this type of file has been associated with TIA Portal, then all you have to do, guys, is go into your folder, go to your last one, double click on it, and it'll automatically open TIA Portal for you. And then when it opens up, you can go directly to what? Yeah, you can go directly to Program View, and then it'll go right there, and it'll save you a few steps. What I can do is, of course, I'm gonna close out TIA Portal. Try to anyway. So instead of me opening up TIA portal, what I could do is I could come out to one of your applications. Then I can double click on one of these folders. And then right down here at the bottom, and this is where you need to have extensions turned on. Now what they'll do most of the time is they'll put the icon for the application that's associated with it. Y'all see this? Okay. The problem is I've got two folders. If that wasn't up there, I've got two files that have the same name. One of them is a program, one of them is just something that's out there, right? So now I can come over to this guy, which is the program, and I'm going to double click on it. When we say double click, we mean double click the left mouse button. And what it'll do is it'll automatically open up what for me? The actual application that's been associated with that file. And so what it does is it saves me a step, is all it does. And then when I get here, it's locked. I don't have access to it. When I get here, what it does is I can just go down there to program view and do what? Yeah, portal view, and then we can pull up the application that way. That makes sense. So instead of me coming through here, it's up to you, but here I could come up here and open these, but I don't have one that has timers on it. And another thing that you can do is anything that you do from here is you can do through program view. So if I go to program view, I'm going to try to go to program view. Project view. So notice one of our so it loads. Oh, I don't know. It don't look like it's doing what I thought it was going to do. I thought it was going to give me the option to open a file, but it's not. For some reason, my taskbar won't go down. Sorry, guys. So I'll just create a new project. We'll call this timers. And we'll also look at counters. So on the Allen Bradley timer, it automatically gives us two coils out there, right? It gives us, what's the two coils? Anybody remember? Enable and done. We can address the enable. We can address that with timer timing, right? You understand? And then we address the other coil with timer done. What you know right off the bat on the Siemens is they don't give you all those default coils. So what does that mean? Yeah, you have to assign them, right? You understand? But you don't have to use them.
Well, you said you didn't have to use it for, right?
On a timer you do, because when you use a timer, now you're thinking about the clock. I'm not talking about the clock. I'm talking about a timer. So we can get by using the clock because there's no on those things because there's nothing required to enable those things. Y'all understand? So if I'm going to use a timer, a true timer, which gives me the ability to set the time, I don't have to choose from a time. If it gives me the ability to set a time, then I'm going to have to use a timer instruction, right? You understand that? We're not going to use a coil, we use a block, but we could use the coil. It's pretty similar. Associated with the timer. So what we have to do is figure out which one indicates timer's timing and which one which output indicates timer done, right? You understand? And I don't have to hook a coil up to both of them. All I need to do is hook up a coil on the one that that I'm using. That makes sense? So instead of us having to look, I don't even have a CPU hooked up here. So it's not going to find anything up there. What's the power supply on these things? 24 volts. So my power supply, what I'm doing is I'm putting it all the way across. So the power supplies that we have is plus and minus 15 volts. Actually, it's around 17 volts, which wouldn't be enough to program this thing. So what I'm doing is instead of using the common in the center, I'm going all the way across. I'm using the negative supply and the positive supply. Or trying to anyway. So, here's something. So can y'all see what I'm doing? So I'm going across. This is my positive supply. This is my negative supply. So what I'm doing, I have this one set for 15 volts. I have this one set for 9 volts, which gives me what? 24 volts. Y'all understand? People think, and we do this all the time, but y'all don't, oh, okay. I don't know. Now that I click on ours. So the way the trainer's wired up, and if y'all went up when we did this is the way it's done. So we have a variable power supply right here, and then it comes over here, and this is red, and then it comes over here. It's got a tap right here, which they call common, and then over here we got another power supply that's pointing this way, and then this one is yellow, and this is variable. So if I make a connection, if I make my circuit connection between here and here, then I get a negative power supply. If I make my connection between here and here, then I can adjust this and I have a positive power supply. If I make my connection between here and here, then what we're doing is we've got two power supplies that are connected up in what we call series 80. And when we connect power supplies series 80, then what happens? Their voltages add together. And you do this all the time. Your remote controls. Very seldom do you see a remote control with one battery. Right? You understand? So you put them in there, but normally you put them, I'm not going to say that. Yeah. I'm not going to say what we said in the Navy, but anyway, you put them in there, positive to negative, and what happens is the voltages do what? They add. So we can hook DC sources, and they have to be the same, guys. If they're different, they're gonna one's gonna get hot and one's not gonna get hot. So we can hook DC sources in parallel, and we don't change the voltage. What we do is we double the current. So if this is 50 milliamps and this is 50 milliamps, if I hook them in parallel, I don't change the voltage, I get double the current, right? So a lot of your remotes will have two sets of batteries, put two in series over here, two in series over here, then they're wired in parallel, right? So we hook them in series to increase the voltage, then we hook them in parallel to get more current, right, out of the batteries. Does that make sense? So what I'm doing is I'm not using the common, and I have this one set to 15 volts. I have this one set to 9 volts, and it's the sum of the two voltages. So in parallel, you need to make sure the batteries are the same voltage level. Because if one battery is 12 volts and one battery is 6 volts, then the 12-volt battery is going to see the 6-volt battery as a load, right? You understand? And it's going to push whatever 6 volts of current through that battery is going to happen. And that's the way you charge most batteries. So like lead acid batteries are voltage charged batteries. They charge on a current, but what you have to do is force voltage back through them, right? You understand? And when you force voltage back through a lead acid battery, it charges. So that's why when you go out on your car and you take your voltmeter and you put it on there, and the car's been sitting overnight, it measures pretty close to 12 volts. You crank your car, it goes up to over 14 volts. So your alternator is basically pushing current back through that battery, right? You understand, and causing it to do what? Charge. So lead acid batteries are we put a higher voltage on them than what we need. NiCad batteries and lithium batteries, we charge them at a certain current rate. So these chargers are really, really small, really smart. So they output a certain current. So if your battery's dead and it comes over here and you plug it into your charger, it might only start out at 1 volt to get 10 milliamps. But as the battery charges and starts needing less current, then what would happen? Your charger automatically increases the voltage to maintain a constant current. So NiCad batteries and lithium batteries are current charged batteries. So if I have a 12 volt lithium battery and said, well, I got a 12 volt car charger, and I come over and hook that up to my lithium batteries, you're going to burn that sucker up. Because it's not voltage charged, it's what? Current charged. Yeah, lead acid batteries, you can put 50 amps on them suckers and charge them, they don't care. But as the voltage on the battery goes up, the current through the battery goes what? Goes down. So this is the way I hooked up mine. And we can series string these power supplies. So I don't know if y'all noticed the other day when we did the counter EMF, all I did was just took multiple power supplies and just hooked them in series 80. And I didn't even use the common, right? You understand? And so I would set this at 17 volts, and then I would set this at 17 volts, and I would set this at 17 volts, and I set that at 17 volts. And how many volts did I get out here? 4 times 17, right? And then, of course, I started adjusting the last one. So we can series string batteries. We can series string power supplies. And what's nice about power supplies, if you series string them, the voltage does not have to be the same. The voltages are additive. If you hook them up in what we call opposing, then the batteries subtract from each other. They don't hurt the batteries just subtract from each other. So that's why if you, in your remote control, if you hook one of your batteries in backwards, then they subtract from each other and your remote don't work anymore. That makes sense? So I fired up my PLC. I'm going to hook up this. Well, now we can go back to the airport. That's something y'all learned back in DC. Didn't y'all learn series aiding and series opposing sources? But you don't. But you see it all the time, but you don't realize what you're doing, right? You understand? So we're going to detect it now. I've got it powered up. It's went through its self-test. So most computers, when you turn them on, they go through a what we call a power on self-test. They automatically go, we call it a post, a power on self-test. And what it does, so when you turn your PLC on, you'll notice the lights come flashing, they'll blink, and they'll doing something. So what's happening is the processor's going through a self-test to make sure it's ready to take your program. If that red light actually stays on, then you know you got what? Problems, you know. Yeah, so if you got some little power supplies, I got tons of computer power supplies, these guys at home. I've been through so many computers. And they're all different voltage levels, and you can just series string them together and get quite a few different voltages out of it, right? But make sure you go negative to positive. You don't want to go positive to negative. You'll make sure when you series them, you're going to go what? Negative, positive, and then you'll take your outputs out the output negative on this side and output positive. So I needed a bunch of power supplies to power up the encoder and then the motor. So I used a bunch of my computer power supplies. I don't know if y'all noticed when I hooked up everything the other day. And then I used my variable power supply to oh, looks like it's doing anything. There we go. So I'm looking at two lights on my PLC. I got a link light and I got a RX-TX, right? What's the link light? Means you're connected, and then the other light that flashes, the yellow one, that means we got. Okay, so this looks good. So we're waiting on the detect button down here at the bottom to on there. It's got a diffuse sensor on there that's looking for color. So then we could see, okay, it's red, and the red has to be this height. If it's black, it has to be this height right now. So we got some red ones that's the wrong height, but it lets it go through because it's within the span. What we do is we have a sensor called a diffuse sensor, and the way the diffuse sensor works is that it transmits the diffuse sensor. The way it works is it transmits light, and then what happens when it hits the object, the light reflects back, and okay. So what we can do on here is we know that the amount of light that reflects back depends on the color.
I think the word is in the little guy, the little robot next door, what was that?
Those were diffuse sensors.
So that, okay.
Now, what it does, it depends on reflection. But what you have the ability to do, even on the Lego robots, is you can set what we call the sensitivity. So what we have on the back of these things is we have a little set screw that I can turn it so it don't see black. So if it don't see black, the only other two colors we have is we have red and we have chrome. Well, red and chrome are highly reflective, right? Because the lights are red. The transmitters are red lights. So red and chrome are highly reflective. Black don't reflect. So what happens if you look at the red ones and you look at the chrome ones, they're exactly the same height. If you look at the black ones are a little smaller. So that's what we do. We say, okay, if we don't get enough reflection, then it's black, and it's supposed to be what? It's supposed to be this high right here. But the problem is we got some bad ones over there. We got a red one that's exactly the same height as the black one. And it still says it's what? It says it's good. And why does it say it's good? Because we can't say, okay, if it's red, it's supposed to be this height. If it's black, it's supposed to be that height. So if we could take the program, modify it for analog, and analog on this, I need to show y'all that. I'll show y'all that later. Analog is really, really neat on this. It's really a lot easier to do than with the Allen-Bradley fields.
Thanks for answering that.
So that's how it knows. It knows it by the reflected by the reflected color. So we have two things. We have a metal sensor over there. So and it assembles it different ways depending on whether it's metal, whether it's black, or whether it's red, right? Does that make sense? So we'll take y'all over and show y'all those sensors. And my PLC is taking a long time for some reason. So what type of timers do we have? Three types, right? What's the three types? We got on delays, we have off delays, and then retentive, right? Okay. Now, what's the difference between an on delay and an off delay and a retentive? Yeah, when you disable the on delay, it automatically resets itself. When you disable the off delay, it automatically resets itself. If you have a retentive timer, when it's disabled, it keeps the time. Okay, and so that would you would have to do what? You would have to reset it. So here's our instruction palette over here. But we also can bring one of these down in here, as soon as it's available. So let's look at the instruction palette. That's probably be the ones that y'all are going to use most often. And what we're going to do is find our timers. And it should be obvious. So we open up our instruction palette right over here.
I thought it was I computer was I see your TF4.
No, it's not usually this slow. I mean, I don't know what's going on. Yeah, so it must be. I could probably close it out and open it up, and it might be a lot faster. So this box I pulled down, this is a box you just specify. So I could start out typing T, and then it would bring up just the timers, right? Does that make sense? So I finally figured out what this box was right here. So that box right there with the question mark, then it can be what? Anything. So and it's a lot faster than actually opening it up here. So here's our general bit timer. So here's our timers, and then of course we're going to have the function block, which is easy to use, and then we have the coils, which you would have to use if you were in the step. If you actually use S7, which is the version before they came out with version 14, and added everything to one application. Originally it was called S7, was the programming software. This is still called technically S7 TIA Portal, right? You understand? And this is what we call version 14, which is the 14th version of Step 7 software. Does that make sense? So here's our timer. So we have, I'll call it TP, T on, T off, and T on R. What's T on R? Yeah, we'd have to look and see what TP is. I don't know what it is. So we come over here and pull an on delay timer in here. And what's some of the things that it's going to ask us? What do we need to specify? We need to specify the time. We need to figure out how we're going to enable this thing, right? You understand? So normally we don't put a timer in a rung without some type of control element in a regular timer, right? You understand Now, if it was up here, all I have to do is start typing in T, right? And then what it's going to do is it's going to pop up just my timer. So what's nice about that is that you don't have to figure out which one of these options, this guy right here. So this is very similar to RS Logic 700, that scroll bar over there. So on 500, you hit the scroll bar, you find a category, you click on the category, and then the instructions that's available in that category pops up for you. And no, it didn't do it. Yeah, so here they are, timer on, right? You understand? And so let's get rid of this guy and do it the way. Dang it. Might let y'all just go ahead and work on your labs, and we'll just take little breaks when this thing pops up, because this is wasting a bunch of time. So y'all go ahead and get y'all's computer out, and I'll just pause this, and we'll just. So, all right, guys. So when we insert a timer, by default, it creates a data block for us. All right, you'll see that. You need to leave this on automatic. Don't do anything there. Everybody okay?
Where did you pull that?
As soon as I pulled the timer over here, timer on, and moved it into my ladder, as soon as I let go, this box popped up. You can assign it a different data block. You can give it a different name. So if you wanted to name your timer, that's where you can do it right there.
Okay. You don't have to.
You don't have to. You can take the default. So notice it's blued out up there, which means it's got access to me, right? You understand? Manually, what you would have to do is you would have to assign it a data block number. If you leave it on auto, every time you open one, it'll automatically take care of putting it so it won't interfere with the other one, right? You understand? So normally what we do is we leave those on automatic and let it assign a number to that. Okay, so here's my timer. So here is what we got. This is my enable input. So what we would do here is we would come in and do what? We'd put some type of contact or something in here that would come up here and control this timer, right? Okay, so that's your enable input. This is a regular on delay timer. So at times when the enable input is true, as soon as the enable input goes false, it resets itself, right? And we'll just use the default tags here. It resets the movie, yeah. If you leave it if you leave it enabled, it'll just sit there when it meets its PT. What's PT?
That's our time.
Yeah, this is our preset time. Milliseconds. So if I wanted 5 seconds, then I would have to come up here and put in for 5 seconds. Okay. And then we enter that, and it'll come up here and tell us milliseconds. It might jump to seconds. Let's see if it does. Sometimes it says seconds. So it jumped to what? 5 seconds. Now, if you enter it like this, 5S, then it will give you seconds, by the way. Then ET.
So you ain't got to type in 5. You type in 5S.
5S, I'm pretty sure. I don't know if you have to put I can't remember. You have to put the hashtag in front of it. It'll tell you a problem. Let's go back over and change it and see if it works. So I'm just going to delete that because it don't hurt anything for us. If it's red, it means it's what? It's wrong, right? It's the wrong syntax. Usually if it's the wrong syntax, it'll pop a red box and tell you that it's the wrong syntax. What is syntax, by the way? It's the way you write something. So syntax is the correct way of writing something, right? So let's do 5S and see if this works. Most people don't tell you this, but they've made some changes on version 13. So if it turns red, I did it right, so it's fine.
So you type in 5S.
Yeah. and that'll give you 5 seconds. So it's blue. Blue is good. Blue means that it's blue means that it's a constant, right? You understand that? Then we got the Q output. This is our timed output. So what are we going to have to put out here? So what we'd have to do out here, guys, is this is where we'd put our coil. Then it can either be a memory contact or it could actually be an output. That makes sense? So I could put M0-0 and that assigns it to a memory coil. It's going to automatically give it a tag. And I can go back and do what? Change tag. Elapsed time, this is timer timing. You don't have to use that. What this will do though is it's going to come up here and show y'all. It'll actually, when we energize this, and I needed to get me some of the little I/O switches in here. When we energize this, what would happen is your timer, it would actually show you the elapsed time over there. All right. Now what you can do is you can assign that to a memory address, and then oh, I don't know. I think you can address it directly. I'll have to look at that. So there's a timer. Everybody okay? Now a counter. Here's our counters. We have high-speed counters. Those are hardware counters, right? You understand that? We looked at those the other day. We're not going to use high-speed counters if we're going to run just count things. If we're going to count extremely high-speed things, then we'll have to use a high-speed counter, right? High-speed counters are hardware. So I could do what? I go to counter, and then these are the counters we have. So what counters does RS Logic 500 have? Count up, count down. This guy's got quite a few options. One of them I don't know how to use. But all you got to do, and this is what I'm saying, even though I learned on the Square D, even though I moved up to this, even though I played around with Modicons and used Modicon PLCs, what I found out is they're basically all the same. Once you learn one, it makes it real easy to do what? Pick up on another. Because they basically, especially ladder, one that programs in ladder, if you see the programs in a different language, it would be kind of hard for us. So here's our counters. We got a CTU. What would that be? CTD would be a what? CTUD would be a what? Up down count. So Allen Bradley doesn't support an up down counter. We would have to use an up counter, a down counter, and then we would have to do a math operation to give us the difference, right? You understand that? So here we have an up down counter, which I haven't used, but I'll play around with it later to see if I can figure it out. So we can bring our counter in here, and then of course, if we don't know the block, then what can we do? We can come up here and click on it, highlight it, and then press what? F1, and it'll bring us up the manual that shows us what each one of these inputs and outputs are, what they do for us. Are you okay? Yeah, just click on it. So we can click on it and highlight it. And then I'm going to come up on my keyboard and hit F1, which is a standard Windows key for information, by the way. So you can do that a lot in just about any Microsoft application. You can hit F1 and it'll bring up an information block. So it should bring up a text thing here. It should take us to what's required for that instruction, right? And see? And then we can come down here and it says, okay, N, this is the what? Start input. PT, this is the duration of the time delay. Q, this is the what? This is the output that is set when the time has expired. ET, what's this? This is the current time. So now I know what each one of these mnemonics or abbreviations on the inputs and outputs of these function blocks do for us, right? This tells us we could use an input, we could use a Q output, we could use a memory, we could use a double word, or we could use a long word. I don't know why we have those. Down here, PT, we can use all these, or we can use the what? Constant, right? And what's a constant? In PLCs, there's very few constants. In computers, a PLC, a constant is, you have to change the program to change the number, right? You understand? A variable is something you can change what? On the fly. Yeah. You can change. So the output of my counter would be a what? It would be a variable because it constantly changes. My preset time, I could get that from probably not from an input. We could get it from an input word, right? You understand that?
But it doesn't change.
Well, that would be a variable. That would be a variable. Anything right here, these would be considered variables because all these are coming for something that can change, right? You understand? This right here, a constant. So if I put a constant, that 5 seconds over there, how would I change that? I couldn't come over here and flip switches. I couldn't come over here and touch it on an HMI panel, right? You understand? Because it's a constant. So I'd have to go in and change the program. I'd actually have to literally go in there and change the program. And so that's what it's showing me. This right here, this blue, it means it's a number, but it's a what? It's a constant. But I don't have to get it from a constant. I can get it from a memory location, right? You understand? Don't know. That's news to me. I'd have to say that. Yeah, and what's neat about Siemens that's a lot different than what Allen Bradley does. The only thing I remember Allen Bradley gives you the ability to do is right clicking on the contact and then changing it from an examine on and examine close, right? Understand? But if I come over here and click on that, y'all see the little red arrow up in the corner over there? That means I can come up here and I can click on that and I can change. It's going to give me all these different options of what we could do. So instead of having to type in that, well, even up here, if I click on this, once it stops, if I click on this, right, then it's going to come up here and give me a text box, and I can change it to an off delay timer. I can change it to an on delay timer. Y'all understand that? Without having to do what? So on the 500, we'd had to delete it and then bring the new function block in there, right? Are we okay? So we'll use the up counter. So this is an up counter. It's going to assign in a block. It's going to assign in a data block for me. It's automatically gave it what? 2. So basically, we leave that automatic. Or now, if I come up here, then I'm concerned with colliding with this thing, right? You understand? So if I assign both of them to 2, it's not going to give me an error. It's just that my timer now would affect my counter, right? You understand? So basically, we usually leave this on automatic. If I want to give it a name, so by default, it's given it the name IEC counter, but I could call it like part 10 or something like that. And then once I do that, now the counters make sense, right? You understand? So this is what we would do, kind of like so notice it calls my counter what? Part 10. Up here it gave you the what? That default name, right? You understand? So you can actually assign that timer. On your program, just about every one of your timers have a comment up there. But what you could do now is do what? Give the timer the name of the contact. I'm sorry, not of your tag, of your what? Of your comments, right? That makes sense. So what do we need here? So we got an R. By default, it says what? False. If this is red, and you just look for what? Good. This would be our what? Preset value. So most of these we can figure out. This would be your counter done, right? Understand? Q. Right? And then this right here, this would be our current count value. So if I can assign it to memory, if I can leave it alone, if I leave it alone, the value will pop up there if you have it in monitor mode. The actual count value will pop up there. Or I can assign it to memory, right? You understand? And then so what we need to do is figure out what this R means. So how do I know that? I'm going to click on it and do what? Highlight it, hit F1. Then I can come down through here and find the chart. And so what's R? Reset. So the Allen-Bradley counters reset. No, they don't. We have to reset that. We have a reset. We have a reset instruction, right? Here, what we could do is we can just assign that to an input and use that to reset, right? So there's the reset on our counter. Most of y'all figured it out. So CU, this is what we're counting. R is what? Reset. PV is what? This is our preset value. Q is our what? Counter status. Or CV is the current what? Current value. So our status would be. Yeah. So what we would do, the current value is, it would show you. And what I said is what it happens is it'll pop up above. It's really, really, really neat. So what we need to do is right now it's false. What would we need to do? We need to put a contact in here, and this would be what we're counting, right? Everybody okay? Then we would need to come over here and put a contact right here. And then this would be, oh, guess what I did? I used an O instead of a 0. I'm sure y'all have never done that, right? Well, I'm using 0 right there. Let's don't use 0 here. Hit it again. It's not in parallel. If it was in parallel, this side would be connected to that side. It's not in parallel. This is my count. This is my reset. This is my preset value. So if I wanted it to count to 100, I would put that right there, right? That makes sense? And then I would come up here, and this would be what I want to do when the timer resets. So I might here assign this to an output. That makes sense? Pretty straightforward. The only thing that's really different is that on the 500, we use a reset coil. Here we don't use a reset coil. We reset it at the counter. This is our count up, and this would be our counter down. Are we okay? This will show us our what? Current value. We don't have to assign that to anything, but I could put that in a memory location and then use that somewhere else, right? You understand? That makes sense? Yeah, so you can't get access to this guy. You have to simulate this. This is not a timer. This is a counter.
I'm sorry.
On my timer, I set this for 5 seconds. Right?
Right.
On my counter, I'm counting up to 100. Huh?
Yeah. I was thinking timers.
By the way, what happens when it hits 100? This guy goes true, but what if I get one more count? No, we don't. Well, no.
I don't remember.
It's just like the Allen-Bradley. If you don't reset it, it just keeps counting. It goes true when you match the count, but it stays true when you match it or exceed it, right? You understand? It's just like the 500, and we would like it to do that because we might not want to lose counts, right? That would be awful if I was counting and for some reason I let counts get through and my counter just stopped doing what? Stop counting. So these counters don't stop counting it just gives you a true on the output when this matches this. But if I go to 100, this is still true. 101 is still true. It's going to keep counting until we do what? Until we reset. Everybody okay? So I'm going to get one of the little data switches. The little switches on here. We'll run this. All right, guys. Are you okay? So we look. This is where you could put it in a memory if you wanted to, but the elapsed time is actually right up there. And it counts as milliseconds. You see that? Okay. And of course, anytime I disable the timer, it automatically does what? Resets. Okay? And now on my counter, then I'm using switch 1 to count. And you can see up at the top, y'all can see where it's counting. Yes or no? So see up here, this shows me the value. It don't show me the current value right here, but this is what you would use if you wanted to store the current value somewhere or use it to compare it to something. And then I'm going to come up here. I don't know why I put 100, guys. Yeah, but here, supposedly when it counts up to 100, it should keep doing what? Should keep counting. But this rung right here should go true when it hits 100. Wait a second. I'm doing something. I'm recording something. So here's 100. Now notice it went true, but what does the counter keep doing? Keeps counting. It don't reset counters don't reset when they hit their maximum value. They do not reset. They just keep what? Counting. But it shows me that it's always what? Finished counting. Well, yes, you could do it. You could use the output. You could use this coil right here, and you could make it automatically reset every time it got up to the count. And that's the same way. That's the same, well, no, it won't loop it. It would just reset when it got up to the count. True, yeah, until I do what? Until I reset it, and I'm resetting it with switch 2, and now we can come up and do what? We can count again. So if I wanted it to automatically reset, then I could come in here and use this coil right here to automatically reset it. But what I would do is I would also transfer the current value. So what I would do is if I needed to use the count value somewhere else, I would go ahead and put that in a memory location, and then I could reset it automatically every time, right? You understand? It's just like the Allen Bradley. The Allen Bradley, if I wanted it to reset, I would use the timer done, and I would put a reset coil out on the right hand side, right? You understand? So it's basically the same. Are we okay?
When it reached the count, the rung went true, but between the stage 3 and the counter, it stayed blue.
Well, that's the count. It goes true when I do this. So it's true, it's false, it's true, it's false, it's true, it's false. So this is my count input. So 13, 14, 15, 16. So this is my count up, right? Understand? And then of course when it comes up there and it hits 100, then it's going to say it hit 100. But then if I keep counting, it's going to keep counting until I do what? Until I reset. Understand? So it's almost exactly. It's just that the Allen Bradley gives me a counter done and it gives me a counter counting. The Siemens don't do that. It's up to you to assign that. But what's nice is on the Allen Bradley, if I wanted to assign it to an output, then I would have to use a timer done to assign it to an output. Here I can either assign it. Guys, I'm up here recording this, and so when I'm up here talking to the class, y'all need to do what? Listen to me. And this gets very disturbing to me if y'all run in to have to do this, and then you have no idea what was going on because why? Because you were talking. Okay, so everybody listen up. Are y'all listening to me? Right? So we had a question that would arise right now is why is this right here blue?
After it reaches county.
Well, no, this is my count.
Right.
So and notice my count is not doing what? It's not counting because it's waiting on me to do what? Yeah, so this is my count, right? You understand? And then when it gets up to the count, so here comes 100, the output goes true, right? You understand? But I can keep doing what?
You said you keep going, it stay.
Yeah, and that's just like that. That's just like the 500. That's exactly what the 500 does. The 500 keeps timing until you do, keeps counting until you do what? Until you reset it. But on the 500, you have to reset it with a reset coil, right? You understand? On here, you don't have to use a reset coil. You reset the counter direct, right? You understand that? Now, what CC would ask, what if you want to reset it when it gets to the count? Well, instead of using a switch, I would just use this coil right here to do what? Reset. If I wanted to store the current value, I would come up here and I would put a memory tag right here, right? You understand?
What would you label the
Well, if it's going to be a true output, so what I'm doing here, of course, before I make any changes, I have to go offline, right? Y'all understand? And then I could come up here and instead of using, so here I'm using a true output, I can just come over here and delete this. And then I can give it a tag and I can use tag 5.
Oh,
okay. So now, when this guy goes true, it's going to generate an output on my output, but it's also where we can use that, right? Y'all understand that? And let me come down here and change this to a smaller value. And I could come up here and take this, and then I could assign it to memory if I using any memory. Now this is where right now it's using setup count. So counters only count what? INT, what's it? Enter. But we have an integer, right? And then we've got a signed integer. We've got a D integer. What's D integer? Double. It's a, right? So an integer would be probably a word, right? This would be a what? Double word, which would be 64 bits, right? Okay. This right here would be an unsigned integer. This would be an unsigned, right? You understand? So that's the options we got. By default, it chooses something for you. But if I wanted to make this signed, then I would come up here and choose that, right? You understand? And then if I wanted to really, really count some big numbers, then I would come up here and do what? So this is a sign. This would be a signed integer. This right here, and this is up on the website, by the way. This is something. So this is an unsigned double integer. That's a sure enough big number that we could count to, right? Are we okay? It makes sense. Since I'm only counting to 25, then just using an integer will be okay, right? Now, what we've got up on the Blackboard site is I want to make sure that I put these up there. These different things, because it's kind of different, because on the 500, you decide what you're using depending on what data file you put it in. So if you put it in F8, then it's a real number, right? You understand? If you put it in N7, then it's considered to be a what? An integer, right? Y'all understand that? But what we've done and what's so neat is that, y'all have access to y'all's Blackboard sites even after you graduate, right? Y'all understand that? So as long as Blackboard runs, you have access to your Blackboard site. So what I've done is inside your class is I've come over here and under reference material. So generic recipe material. So hopefully we got data types in here. Data types. So this tells us what the data types are, and these tell us what ranges we have. So an integer would be a what? 16-bit number. Right? You understand? But this is signed. This is signed. So what we do with 16 bits, we get 65,536 combinations, but we're sacrificing half of them for the signed bit, right? You understand? So over here it says I have a range between 32,768 up to a positive 32,767. Why do we have one more negative than we have positive? 0 eats up one of your positive combinations, right? If I specify an unsigned integer, then we get the entire 16 bits. I'm sorry, if we use unsigned double integer, then we get, by the way, this is the way Siemens says that's a hexadecimal number. It puts 16 and puts a hashtag out there. So if it pops up and you see that 16 with a hashtag, then those numbers it's showing you're in what base? Hex. So this is an unsigned double integer, then this is the range we get. We can get what? 0 to 4 billion, right? What am I at? 4,994,967,297. That should take care of almost anything we got. If I use the double D integer, right? This is unsigned. This is what? Signed. Then what we do is we take that 4 billion something divided by 2. We take one off for the positive. We put one off for the what? Put one off for the negative. If we use real numbers, what's a real number? Well, we have 32-bit real numbers and we have L real numbers, which are unbelievable. So a real number has the ability to use scientific notation. And that's just like your calculator. So your calculator, if you tell it to do math that it cannot represent as a number, it automatically shifts into engineer notation. The problem is when it shifts into engineer notation, what did you lose? We lost accuracy, right? It's just like pi. So pi is 3.14159, and how long it goes on forever. Well, the more you round it, the less accuracy. Once you shift into engineer notation, the less accuracy you get, right? You understand that? But it gives us the ability to handle. Look at that. And why they have two different negative ranges, two different positive ranges, I have no idea. But look at that. 1.7295693.34.34862 times 10 to the minus 308th power. That's a little number, right? Down here, but if it shifts into this, we lose what? Accuracy. I know what Allen Bradley does. Allen Bradley uses a 32-bit number. And as soon as you exceed 24 bits, it shifts into engineer notation. So that means it would be accurate up to 2 to the 24th. The RS Logic 500 would be accurate to 2 to the 24th. As soon as you go up above 2 to the 24th, then it's going to shift into engineer notation. Scientific notation, and then you lose what? You lose accuracy. Right? You understand? Everybody okay? So it's just like your calculator. As soon as your calculator shifts into scientific notation, what does that mean? The number's not as accurate. But most time, especially in engineering, you don't have to be perfect, right? You understand? A lot of times you don't have to be perfect. Okay? So L real, these are the big guys, real numbers. This is what RS Logic calls floating point numbers. Double integers, right? Unsigned, signed, unsigned. That makes sense? So the signed numbers would be from 8, 0, 0, 0, 0, 0. You use something called two top. Another thing that we have on there is these data type symbols. So this is what you would do to address these things. So if I use N, then that's going to be a bit, right? If I use IB, it's going to input a whole what? Whole 8-bit, it's going to input 8 inputs at the same time. If I use IW, then it's going to input a what? A whole 16 bits, right? Okay. If I use ID, it's going to be a what? Double word, which is a 64-bit. I need to check that because that looks wrong. Q would be a what? A bit. Q is an output, but we can output one. We can update one output at a time. If I use QB, I'm outputting what? I'm updating 8 at a time, right? You understand that? So that's what y'all using. So when y'all clear out your outputs, you're using QW, and then you're saying 0. Well, QW is what? That's a whole word. So you're actually clearing out 16 outputs. We don't have 16 outputs, but we have over 8, right? You understand? So we're clearing out bits that we don't even have. That makes sense? QD would be a what? Double word. I need to come back and check this. So that's the way you change your instructions up, right? You understand? Yes or no? I think memory's next. So memory M would be, if I use M followed by something, that's going to be boolean, which is what? A bit. If I use MB, I'm dealing with a whole what? Byte. If I use MW, I'm dealing with a what? And if I use ND, I'm dealing with a double word. This right here is wrong. This is not my chart. They're giving it the same number as this is, right? Okay, so that's the way you change your addressing, right? Does that make sense? Huh? Yeah, it is. I mean, well, it's smaller. Yeah, you're right. The byte is wrong too. So the byte should be 0 to 255 addresses, right? Let's see what they're saying up here. Yeah, so this chart is totally wrong. Whoever did this is wrong. So a byte should be what? 0 to 255. A word should be 2 to 65,536. I mean, 65,535, right? And then a double word should be 0 to 2 billion, something. That's not one of those numbers I have floating in my head. So I'll go back and change this chart. This chart right here is not mine. Ain't that amazing? Y'all did a good job. Y'all saw that was what? Yeah, that had to be wrong. Okay, guys. Okay, guys, y'all look up here just a sec. This is another thing that I forgot to tell y'all. You can bring up the information on a block by doing what? Clicking, highlighting it, and then hitting what? F1. If you want to see what an instruction does, you can just hover over it. Hover over it just means put your mouse up there, and eventually it'll come up and pop up the little yellow box. You go down here and hit count up, and then it'll do this. It'll bring up the same page for you. So here you can actually look and see what's required or what the thing does before you insert it into a program and hit F1, right? Y'all understand that? Which is pretty neat. Okay, that's it. Okay, y'all listening? So this is the up-down counter, which we don't have available in the RS Logix 500. Y'all listening up? Yeah, we don't have it available in the RS Logix 500, but the 5000, well, we're going to start looking at that too. But I have a preset value. So here my preset value, I'm putting what? 25, right? And, so what happens is now I can come up here and I'm using switch 3. Okay, and what is it doing? It's counting up, right? Everybody okay? And it'll keep counting up until it hits my what? My preset value. And then it just keeps going. And then if I hit count down, it starts counting down. And when it gets below the preset value, it should go back what? False. Everybody okay? And then of course I can come over here and I can reset it. Which switch? Oh, sorry. I can reset it with switch 5. And it resets it to what? 0. This one, by the way, comes up to be false.
What's that say at the bottom?
This one comes up to be false. So I brought a contact in here. This is load. Okay. Now what do you think it's going to load it with? Preset value. So what we're saying is if I use this, then I could load it, right? So I'm going to hit load. So by default, this comes up to be false, which means you're not using load. But if I come over here and use the load, then it loads it with a what? Load it with whatever you put in the preset value. So now if it stays true, I know I'm above the preset value. If it goes false, I know it's what. Now I can make decisions with this guy right here. So if I assign CD, which is the current value, then I can store that in a memory location, and then I can use my compare operation to say if it's equal to this, do this, and if it's equal to this, that, do that, right? Do you understand? Yes or no? So this CD value, the CD value on the counter and the timer is like the accumulator on the 500. So if you wanted to use the accumulated value, you'd say T4 0 dot a accumulator right over here. What we would do is if we can either use it or not use it, I can assign the CD value to a memory location. And then I can say, okay, if the contents of that memory location is greater than this, right, I can make it do one thing. If it's less than this, so I could use my compare instructions like we did in PLC2. You understand? So if we don't need the CD value, we just leave it blank. Are we okay? That makes sense? Okay. So that's the up-down counter. It's pretty cool.
So you don't have that in Allen Bradley?
Well, we don't have it in 500. So all the PLCs that program with the RS Logic 500 language doesn't have an up-down counter. But we can simulate it by having an up counter and a down counter. You listening, Jobert? And then using a math instruction to add them together. Then if it goes minus, it actually would add a minus number and it would do subtraction. So we could simulate it. We could do the same thing with two different instructions. That makes sense? Now the 5000, the RS Logic 5000, it wouldn't surprise me if it didn't have an up-down counter. Because that's the newest version that they have out there. But it doesn't program any of the PLCs we have over there. It starts with the compact logics. So all we got is the micro logics.
So you think you got to swap out all the PLCs over here to run the new program?
Right. To program a PLC, we would have but what we're looking at is trying to get these things right here. And then what we can do is we can put whatever PLC we want on them and use the switches just like you do on the 504s over there. So we can teach PLCs on one of these, no matter what PLC it is. Yeah. So the 504s over there, those are true modular PLCs. Those have the rack and the backplane and all that other kind of stuff. The modular PLCs we have now come with so many fixed ports, and then you can do what? Then you can add it through. It don't have a true backplane.